Okay, so here we are in the lab again. And so I wanted to give I'm going to start doing project updates just to just give an idea of the flow of the lab and the flow of the projects and update stuff for people that are really interested in the specific projects. All right, so first, I am working on the the motion board, and I discovered that I made a mistake when I did the design for the front end because the front end for the peripheral boards allows multiple boards to access the SRAM on the bus. So you can have multiple boards connected to the bus. Only one can read and write at a time, but they all connect to the same bus to the same SRAM that's on mainbrain. So we have buffers that can get tri-stated for the address and the data buses so that there's no conflicts, no bus contention. However, I made a mistake in that I overlooked the fact that the read write, the output enable, and the chip select that go to the SRAM from the I/O boards, from the peripherals, need to be able to be ORed, because when one board takes control of the bus, they take control of those signals. So if any other board on the bus is holding those lines high, which they would be, then you got another board trying to pull it low, and that's just simply not going to work. So they have to be able to be ORed. So the only way to do that, because for instance, the read write is and the output enable are controlled by the PMP, so a module. So you can't configure it as open drain, because the data sheet says that you really shouldn't do that while you're using a module like that. So, but in any way, if you do that, that line, the read write determines the direction of the buffer for the data bus, and it also, when you write, it has to turn on the the address buffers. So if you do open drain on that before the buffers, then it's going to mess it up. So it has to control the buffers first. Then after the buffers, it has to become open drain. So I have to add one more buffer and buffer 4 or 5 lines going out to the SRAM, and that will be open drain. Open collector uses a transistor, and open drain uses a MOSFET. So we're going to do open drain and see if we have any problems with that. We shouldn't. So then that changes a little bit of a design on mainbrain itself. So all those lines that get converted to open drain have to have a pull up. And so I'm starting with the 10K pull up on mainbrain, because you don't want pull-ups on each individual board, because you have a 10K and a 10K and a 10K, and each time it's chopping the resistance down. So you have a different pull-up current with one board in and a different one with 2 boards in, and the current keeps going up, and we don't want the current to go up or change or anything. So we're putting the pull-up resistors on mainbrain, so it pulls the lines up, and all the other boards, they just have one set of pull-up resistors on mainbrain, which simplifies it and reduces cost, even though the resistors don't really cost that much. But it's simple is better, cheaper is better if you can get away with it. And so we're going to put the pull-up resistors on mainbrain. So mainbrain gets changed slightly, so there'll be a new rev on that. And I intend to have some boards cut for myself with the latest as soon as I'm done testing. And I put those, the Fusion project file updated for mainbrain. I put that on the website, and I put the Gerber's design files on the website, and that's at antimatter.me. And you should be able to navigate through it. It's under design files from the left-hand menu. Okay, so then in the background, you see the 3D printer is printing, and it's like 90% done. It's almost done with that part. This is going to be a part for my robot project. So the motion board is going to control an axis, and there'll be a couple motion boards, and then there'll probably be an I/O board, and they'll go on into a body. That is one section of the body. So there'll be 3 or 4 pieces, and it'll be a long body, and there'll be batteries in it because you have to have 24 volts for the motor. So there'll be 2 motors, 2 motion boards, main brain, and at least 1 I/O board in there that will control it. And so I'll probably start making videos sometime on the robot project as well. So I made an interesting mistake. When I ordered the part for the flash chip on MainBrain, it didn't pass test when it boots up. It reads the manufacturer ID and the chip ID, and they failed. And I'm like, what's going on? And I mean, it failed like in a random way. It's just garbage data. And so I got looking, and it's what I did when I ordered the chip. MainBrain runs on 3.3 volts. I ordered the 5-volt chip. So if you slow down the access time on the chip, it actually works, except it fails because it gives you the wrong chip ID. But it does work if you read it slower, which is kind of funny. So that's just a little mistake. That's not a design thing or nothing. I just ordered the 5-volt chip instead of the 3.3. So that was kind of funny. So that's kind of an update of what we're doing in the lab and the projects and stuff. So I'll see you in the next update.